We'll come back to the ants later. In the meantime, thanks, ants. Thanks. You don't have to be a brain surgeon to operate on the brain, but you will need some training.
Thank you for your patience, everyone. Oh, Jesus. Alright. It will become clear in a minute as to why I'm running really late. Trust me on this. Hope everybody is doing well. Oh, Jesus Christ. Okay. Here we are. We're here on a Monday. Another freaking Monday. Only this time our main Monday project is done. Hey, Adventure Josh. Adventure Josh says, this scene is giving me strong Atari 800 vibes. Possibly. It's nicked from Space. Well, I don't know. I nicked the scrolling background idea from Space Harrier. It's written in GL shader language. Yeah, it's like a mixture of oh, never mind. It's so good. Okay. Let's actually hang on. Let me just cut over to desktop mode. Hey, how's it going? Okay. Shit, my camera's in the wrong spot. So, new project. So yeah, past year and a bit, we've been doing game dev on Monday, and that's all done mostly. I do not have to worry about that anymore. If I will pin it. Actually, yeah, I should pin it in the chat. So if you've if you want to check out the game, that I've been working on for the past year. It's there. You can play it for free. It's in the web browser. It also runs on MS-DOS. It's all very good. Now, as a follow-up to this, well, not even as a follow-up to this, another project which I've been meaning to work on, but I've kind of put off a little bit in lieu of doing game dev, and now I got to really get my skates on and figure out what's going on. Is that I kind of offered to do a circuit bending workshop, and on the assumption that I'd be able to kind of learn kind of how to do it in the nick of time. So that's kind of what we're going to be looking at today. Hey, Queerman. Oh yeah, that's right. Sorry, I'll move the infinite mirror void over here. Oh yeah, the other thing I was looking into, as you can also see from my uncleaned up desktop, is that there was in the last couple of weeks a Laserdisc emulator, or rather like a Mega LD, which is the Pioneer Sega Laserdisc system, finally got emulator support. And I was just having a look around at what games were playable. Actually, yeah, like, I really wanted to look at I Will, the Story of London, because I've seen it being played, and it is just absolutely nuts. However, I got as far as downloading the, what's it called? So, archive.org has a 90 gigabyte raw Laserdisc. It's basically just the raw RF signal from the Laserdisc, which apparently you need to run through 2 or 3 intermediate steps in order to get a image that is playable in the emulator. So I will look into that on my own time, but I'm excited. Like, there are some titles on the Mega LD Laseractive which I'm super keen to play, including apparently the best version of Road Avenger / Road Prosecutor was on here. So yeah, anyway. That's for another time. Oh, Queerman says, I love your top. Thanks. It is it is a boiler suit by Suck Workwear. And alright, so what we're gonna do tonight, you can see, if I just pan the camera down, you can see here that I have a child's piano sitting here on my workbench. Actually, hang on. Let me take one of these handy sandbags and buttress the tripod so it doesn't fall over, because that's exactly what it's going to do. So, to give a little bit more, actually, hang on. I can switch to close-up mode. Okay, so here we go. Here is the Fisher-Price child's piano. You can turn it on. Piano, please. Anyway, you know, it's a child's noise-making toy. This one's actually quite recent. It's from about 2018. Yes, acquired at a charity shop for not very much money. But what I was interested in looking into is that I'm not sure if you've heard of a little thing called circuit bending, but that is essentially when you open up one of these toys and then make some unauthorized modifications to the electrical circuits inside the toy, and thus make it sound a lot cooler and I don't know, potentially more glitchy. So I mean, this is like, I have a few of toys of this type just kind of sitting to one side in my parts bin, which I kind of need to look into. So I figured that what we're going to do tonight is I'm going to open up this child's toy. We are going to, I guess, first have a look at what guts are in there. I'm guessing because it's a newer toy, it's going to be like a fairly basic circuit. Like, I imagine it would just be a glop top attached to a bunch of keys. And then we'll see what we can do. Hopefully there'll be some discrete components in there. I'm hoping that at least there'd be like a clock source or something that we can mess with. But yeah, I don't know. I've not properly done one of these before, so I figure that we might try with this one. If we come up empty, I might pick up a slightly older toy and see if that comes any easier. But yeah, it's based, yeah. But yeah, the plan is essentially, I mean, this, yeah. So over in West Australia, there is a little kind of gathering called Pox Eclipse, which is kind of a Mad Max themed festival. And I guess like one of the unofficial themes of that is like making things out of trash, or making do with trash. And like with these, there are just so many of these noise-making toys that are just sitting around in charity shops, because usually, well, because they have like a short, I guess a relatively short kind of shelf life in terms of the child being interested in them, and also the parents hate them. They just kind of, it absolutely drives them insane. So every kind of, I don't know, I see modding something like this as a way of saving it from either just landfill, basically. So anyway, that's kind of what we're looking into today. So I guess first up, we should try and open it up. Oh, here we go. Adventure just says, so we should send you 1970 Speak and Spells. I mean, if you really want to. I have... Oh, actually, yeah, just 1 second. I have the Texas Instruments Speak and Music right off screen. In fact, I've got 2 of them. I'm not going to reach for the other one because it's a little bit too far away, but is this one got batteries in it? It does not. Okay, so I can't... I don't know, the follower alerts, some of them are from the TI Speak and Music, but yes, these are beautiful 1980s toys. And they also have quite a lot of passives, which means they're apparently easier to mod. But of course, I mean, like, the temptation is to go on eBay and like find toys that you want to mod, but that's not really going in with the spirit of like, I just want to go to any charity shop and get a an unloved children's toy. That said, I've really been tempted to buy a Furby, because it'd be cool to figure out how to break a Furby. Yeah, Adventure Josh says, the early ones have a full CPU and ROM and a bunch of discretes to make the sounds happen. Yes. So the toy I just showed you was from about 1985, and that was the point at which they started making discrete chips which contained both the, it was like kind of a custom chip which contained the CPU, the speech processor, and the ROM data, which is a little bit unfortunate in the sense that, I don't know, if you want to dump it, you have to decap the chip. You can't just take a ROM out anymore. But yeah. All right. Oh, I should put on some background music. I should turn that off. Yeah, cool. No, not the scripting API. I've got all these like DOS development windows, all these like DOS development tabs open that I can close now. It's incredible. I haven't quite come to terms with it yet. What are we doing? We're going to chiptune.app. That's it. Let's go. Let's try OPL Archive. Be even better if I route it through the right sound card. Oh, Adventure Josh says, the early ones have a full CPU and ROM and a bunch of discretes to make the sounds happen. I found myself around a month ago trying to talk about early speech synthesis and realizing I knew less than I thought, so I did a bunch of digging. Oh, there is actually one other thing that I can probably show on stream regarding that. One moment. So this here is a little board that I put together containing, I'm not sure if you can see the chip ID here, but hang on, I'm gonna turn it around. Come on. It's a TMS 5220 CMS, which is one of the later Texas Instruments speech chips. I mean, like, I was interested in playing back sounds from arcade boards, and they generally use, like, the older TI speech chips. So I wrote in Python some code to cross-convert them, if that makes sense. Like, because, like, the sample format, it is actually samples. It's just kind of converted to an extremely low bitrate. And, yeah. It's just a case of, like, getting the lookup table from each chip and, I guess cross-converting the sample formats between them. Alright, where is this? Okay, that feels like... Ah, there we go. So if I plug this in, I think it's still flashed. So that's just playing samples from the Chrysler talking car, and this potentiometer over here. All that's done is with this speech synthesis chip, there is a RC circuit, so it's like one resistor and one capacitor, which determines what the clock speed is. So given that this this potentiometer, it is a variable resistor. We just chuck that in there, and then you can suddenly adjust the clock speed of like how fast digital audio gets played back. Because so I've got like a little teensy here which contains the samples on it and the commands for playing it back. And I think it listens to the interrupt lines, I think, from the chip to see whether or not it can like latch in more samples. So. Yeah, that's what that was. Okay. Hang on. Oh, it's here. Alright, so let's crack it open. Adventure Josh says, yeah, I was surprised that the original two market solutions were TI's specialized sample-based approach, and I think General Instruments' custom circuit approach, which seemed quite different, but probably if you dig a bit deeper, are fairly similar. Possibly. I'm not aware of. Are you talking about kind of like the business model of selling all-in-one chips as opposed to like sample banks? I don't know. I think the TMS chip that I had on that board, I think the reason why there's like a ton of them on eBay, and I believe that's because that was the chip that they mass produced for like the home computing market. And so there's quite a lot of board pools and factory seconds just sitting around. Oh, Adventure just says, I bet the custom circuit has encoded the phenoms in there somewhere. Yeah, it, the chip would just have ROM in it, and that ROM would contain, not the phenoms, but like it contains, I don't know, the samples are like stored as like I think voiced and unvoiced thing. I don't know. It's been a while since I've looked at the old TMS chips, so I'm not entirely. I can't remember exactly what the terminology is. Probably should have used a media screwdriver. But that would require getting up. Okay. There we go, it just opens up. So what have we got? We've got... So on the front there's this sliding mechanism, which allows you to pick the program. It is literally just a piece of... I see, okay, so it's a piece of plastic that slides across these little kind of pogo switches here. And then whichever pogo switch is held down is an indicator of what the, what program is need to be run. Obviously, we've got a glop top. So yeah, that'll be the system on the chip and everything. Underneath that beautiful blob of epoxy, just to keep everything inaccessible. And we have two. Okay, we've got two capacitors. We have this little guy. Some surface mount components. This is the power on switch. Oh. Okay, and then the keys, I'm guessing they have their own, like, there is this piece of plastic which is holding them down, but I assume that underneath there would be micro switches underneath all of these. Okay, so may as well unscrew this headboard. Oh, and I've already lost the... Gotta keep that over there. Take that off. Then the keys just kind of come out from underneath. Oh, okay. So the micro switches, I guess, are on the Oh, okay. So there's actually nothing underneath the key, as you can see. I'll just pull these out just to show. There is, in fact... I'm not sure if we can see the right angle here. You can kind of make it out. There's like a little rubber dome switch on the underside of the board, which is what like this cantilever pushes up when you push the key down. So that's a choice. I guess it, you know, keeps things. I guess it keeps things mechanically simple because you don't have to have anything mounted in here, and you don't have to pay for any more. You know, you just have like one little compact board. Okay, and what markings have we got on the... We've got... GX R68 multi-language main R201 PCB. Yeah, we've got the battery compartment which is hot glued. We've got this incredibly cheap plastic speaker and this breakout board containing a multicolor LED. Oh, Mamu says, disassembling stuff on stream has the advantage that you can go back and see where the screws went. Yes. Mostly there aren't that many screws. Though, I do notice that one of the screws was already missing when I opened it up. On this, on this piece here. Either that or I've somehow lost it. But, that can't be right. Okay. So we don't really get yeah, so unfortunately, this probably isn't going to be super easy. We have some passives, but they are they're pretty freaking tiny. Interestingly, there's like a space on the board for a push button here, which is not filled in. And I guess each of these switches also seems to have a capacitor near them. So let me jam all these screws over here. Okay, skip. Sorry, yes, crushing ceiling. I just realized. Hang on a second. If it's loud for me, it must be deafening for you. So I better turn that down. I don't know. One day I'll figure out like why the audio ducking only sometimes seems to work. Okay. So I think what I'll do is I'm gonna unscrew this board just to see if there are any kind of better, I don't know, to see if there are any like kind of anything useful on the bottom. Because yeah, the problem I think of like newer toys like this one is that as you can see, it's not really designed to be modded, or you know, there's no through hole components, no nice big meaty vias. It's just like the tiniest of tiny surface mount stuff. Oh, Racing the Beam is asking, what was the name of the AdLib tracker I was using the other week? That was Reality AdLib Tracker. Reality AdLib Tracker. Okay. So I might reassemble the keyboard in a little bit. Adventure Josh says, it looks very Fast Tracker 1 in its styling. I guess, I mean, like, doesn't most tracker software look like Fast Tracker? Or at least a variant of it. Okay, so here's the underside. That's actually, okay, that's actually not too bad. We've got some test points. Wait a second. Wait a goddamn okay, hang on. I'm very excited now. See what we've got here? I know this is like absolutely against like the point of circuit bending. But what we have here is... Oh, it's upside down. You won't be able to read it. We have here a bunch of test points which are labeled things like SCK, which generally means this thing can be attached to a J-Link. And now I wish I remembered where my J-Link was. It's probably in the cupboard behind a bunch of crap. But That could be... Honestly, though, that opens up a possibility, because if this thing is J-linkable, and this thing has flash memory on it, which potentially it does, because, like, flash memory is super cheap now, and they've obviously, you know, spun this board to be, like, available in multiple markets, we might be able to dump the ROM and change the samples to be something else, something that is not approved by corporate. So... Oh, I'm so glad I turned over this board now. This is exciting. Okay. Because, yeah, what have we got? We've got data, we've got clock, we've got res, we've got S-clock, VCC. Yeah. And then some just kind of interesting ones over here that are test points. But, yeah, like, but they're all kind of nice and big, and they're designed for pogo pins. So, like, the idea would be that you'd, like, stick this board down on your test jig in the factory, and then it would run through and make sure that the board passed QC. So... I don't know. I remember this song. Sonical has this on his playlist at sometimes. Okay. So if we like look at these, tests. Oh, okay. Race in the Beam says, what's the IC next to the glob? Could that be storage for region-specific audio? That's a good question. It's a tiny chip. Let me see if I can get a magnified, magnified look at it. Okay. Well, that's definitely a number. I have no idea. Like, it's only 4... Sorry, it's 8 pins. So, it could potentially be... what's the name of that, like... What's the name of that type of memory that only, like... That's in, like, a SOP 8 or whatever that form factor is? I don't know. I'm not an electronics person. Usually. Yeah, it could be SPI flash. So I'll look up the... Let me just look up the model code. Alright, get out of here. So it was Z5V80066. Might be 2. Ah, okay. Let's check if this is an 8-pin. Yeah, 25 volt, 8066. Sector size. Okay, so if it's anything like this, it would be 4 kilobytes, 64 kilobyte block size. You're not going to just tell me like how big, I mean, I'm guessing it's some multiple of those two. Oh, okay. Is there... Yes, datasheet. That's what I was after, not a comparison. 8 megabits. Okay. Yeah, that's probably going to be our sample memory, isn't it? I see. Okay, so sports general serial peripheral interface mode 0, mode 3. 8 megabit serial NOR flash memory, which is configured as 8 banks of 1K. Oh, sorry, 8 banks of 1 million bytes. Okay, so yeah, it's an 8-pin SOP. And looking at the pinout, so the top left is going to be chip select. Which one's going to be? Okay, yeah. Pin number 4 is attached to ground, so this is correct. And pin number 8, we can. Hang on, where did my multimeter go? Oh. Must have hidden it. Hang on. There we go. So here we go. Is that the power line? Okay, there must be some kind of regulator. Oh wait, okay. This is where the power comes in. Yeah. That doesn't matter. Okay. Well, I don't have any I don't have a chip flasher that, one option would be to like desolder this and put it into a chip flasher, but given that this board has debug pins on it, maybe we should just chance around with the debug pins if we want to try and flash it to say something else. Okay, so let's take these out of the way. But I do like these test points. I do like how the board has got quite a lot of them. So maybe the trick should be and they appear to be on like pretty much every line too. So I think what I'll do is I'll go over and get my giant coil of wire and start soldering to these test points. Just so we can get like a bunch of wire, and then we'll attach the wire to this, which should then make it a little bit easier to test things. Okay. What do I need? Alright, let me put that over here. I have negative space on this desk at this point. Actually, that goes on the floor. First, we've got to eject this. Come on, guy. There we go. Okay, board is free. Where is... Oh, okay. Okay. Oh, yep. Almost forgot. I don't know where my old, almost spent flux pen went, so here is a newish flux pen. So let's have a look. Okay, so in order to be unobtrusive, we really want quite a bit of wire, actually. Enough for it to kind of run out the back. I mean, there are these convenient vents. We could always just punch one of those open. But I think we should probably standardize on a fairly longish piece of wire. Actually, my bad. Let's go to 60 centimeters. Thereabouts.
Was it because the Townsends had recently rewired their home? But then
Very apropos, crushing ceiling. Okay.
Yes, well, that was a lot of fun, but good things, they say, cannot last forever because Very soon after the program, someone stole all my synthesizers.
No,
Hello.
not the synthesizers. That's okay. We're making new ones. That's what this is all about. Okay. I'm gonna have to do a little bit of reorganizing of the mess now because I want to start, or at least want to have a go at like soldering some things under here, but that will require the soldering, what do we call it? So right now it's on the left-hand side of the desk, and it would need to be... Oh, actually, okay, that's not too bad. So if I just kind of clear... Alright. Whoa. Okay. That could be worse. Okay, so... That's good breathing. Alright. So, let's just try... Actually, before we do that. So we cut this down so it's like nice and short. Then we melt a tiny amount of solder into it. Okay, so that's tinned. What we need to do now is similarly melt a tiny amount under here. There we go. So good. It's one of those moments I wish I had another hand. Just to... Actually, maybe I do. Oh wait, no, there are no alligator grips on. Okay. Okay. We'll just tack it for now. Okay. So that's about a good length. So I think what we'll do is we'll grab several lengths of wire that are about that long. All right. So yeah, I'm twisting the wire ends before I put the solder in them because that makes it less brittle. Hopefully that's enough. And generally you want like the literal smallest amount of solder possible, because you know, if it gets too blobby then it also becomes kind of like a bad, like it's like a cold join. It's not great. So I'm just adding just enough to the pad to tack it down. There we go. That's actually quite a bit, but we should be alright because we're gonna attach this. Oh yeah, also order of operations, I should probably do that one before this one because it'll be easier to solder. There we go. Wait, what? Alright. So that pad does not want to take up new solder at all, which is where our friend, the flux pen, comes in. This flux is this magical substance which makes solder want to attach to things. Come on. There we go. Probably a bit too much, but that's okay. I'll just preemptively wipe it off there. So now hopefully there should be no problem in there we go. Not the best joint, but it'll do. It'll do just fine. That pad's got solder, that pad's got solder. This one needs a bit of solder. Gonna go? Oh, okay. I got it, but at what cost? Okay, I'm just gonna move the soldering station a little closer so that I'll be able to more easily work with it. Okay. Right, this is the one I just lost. Not super nice joints, but they'll do. Crap. Alright, those are all test points that were coming from the LED, that's right. Okay. Okay, so those test points are all about. So I guess we've got like these test points here, which would be measuring for the sliding switch on the top of the keyboard, and then these test points here I think would be for checking the status of the keys being pushed down, or testing the, you know, delivering a key press maybe. Okay. So I definitely want to attach wires to like where all of these press buttons are. That seems like it would be good. So I gotta just get soldering then. Does that? Is any of that flowing into the damn pad? Well, judging by how soggy my soldering iron is, I'm guessing not. Okay, come on. Come on, magic flux pen. That's good. So... Actually, what am I doing? I just realized. What I should be doing, I've been like going, huh, how come all these joints are turning out really crappy? What I should have been doing is holding it in place, like, holding the top bit in place with tweezers rather than with my stupid hand. And that way, you get a nice, much nicer joint. I just forgot. That's all. Come on. Come on. You know you want to melt. I'm giving you permission to melt. There we go. There we go. That's a much... probably doesn't show up on camera, but that's less scraggly. It's kind of more shiny. Generally in soldering, if like the shinier and cleaner it is, the nicer it is. Mambo says I would have fried that circuit several times by now. They're pretty resilient. They can, like... hardware can take, like, quite a lot of... Especially children's hardware. It's designed to take quite a few knocks. Alright, let me just fix up my atrocious... Just going to commit a little sin, which is putting solder on the iron as opposed to putting it into the joint. There we go. That's a little better. It needs more. The joint is thirsty for more solder. Come on. There we go. Nice. It's coming back to me now. Basic soldering, I don't know. Basic non-bad soldering 101 is, it's not quite with me, but oh yeah, okay. If I'm being really honest with myself, I should fix up the one that's underneath here as well. Okay, come on. Come on. Get off. Okay, there we go. That's shiny now. And finally this guy. But yeah, with the tweezers, it becomes much easier than with your stubby fingers to push the tip of the wire down onto the board, or hold it down onto the board, which then means that when the joint is formed as the solder cools, the wire doesn't pull away, which is generally what happens when you push it with your fingers. And you know, you probably could do this with your fingers if you didn't mind getting burnt literally all the time. But I just don't have what it takes, unfortunately. I gotta cheat. I gotta use tweezers. There we go. Oh yeah. Okay, let's take this. Actually, yeah, maybe what I'll do is, in this window up here, we'll have a photo of what it originally was, which was Fisher Price, Life and Learn. There we go. Okay, come here. Come here. Alright. That joint definitely needs a little more. Just a little more. Come on. Come on, let it solder. You can do this. Okay, oh, okay. So, there's one touchpad up there. touchpad there. Come on. Is that wire tins? Sure. forgot that there is some tiny wire cutters inside the wire stripper. But it's okay. I just pinched myself, didn't cut myself. Don't make that mistake. I don't recommend it. Come on, help me out here. A little dry. A little dry. Ah, crap, no. Alright. So what have we got now? We've got 1, 2, 3, 4, 5, 6, 7, 8, 9. No one there is marked ground. So I need to get ground. May as well solve this one up, but we'll get ground and then VCC, and then that should give us. I don't know, we can start poking at stuff. Hopefully. great. Okay, I'm trying. Hey, Absentia Nihil. Not the silly sounds piano. Is it going to make it, Doctor? I'm confident that it'll survive in some form. We did notice that on the other side of the board there is a SPI flash chip which contains 8 megabytes of samples. And there's also debug pads over here, so potentially after the break we might I might break out the J-Link and see if we can reprogram it, but for now I was just kind of like attaching wires to all of the contacts so we could just have a play around. I don't really have like a set idea of what I was going to do with this piano. Yeah. We're just trying stuff. That's all we're doing tonight. We're just trying stuff. In my case, I'm trying to be competent at soldering, but it is semi-successful. Come on. Okay. I'm trying to solder the ground. I'm trying to solder to the ground plane, which is difficult because I mean, like, yeah, most PCBs, you see how there's this kind of like cross-hatched green fill? That's what's known as the ground plane. So it's just a big bunch of copper which spreads along the length of the board, and that generally means that it takes more temperature to heat up the pad that's attached to ground than other pads. So alright, well that seems to be fine. Okay. Then we just have to attach one to VCC, which should be our battery pack. Also, I just remembered, I keep saying J-Link, but I do also have a Glasgow, and I've not actually tried using my Glasgow yet. But apparently that's good if you have mystery debug pins for figuring out how to communicate. Though by that same token, I mean, J-Link is quite nice. Does kind of do a pretty good job at auto detecting a bunch of chips. So, a little bit of flux. Ooh, that flux smells great. Definitely should be breathing this. Come on. It's real simple. You just gotta flow into the joint. Flow into the joint. There we go. It's blobby, but I'll accept it. Okay, good. Well, they're not falling off, so there's that. Let's turn the hot piece of metal off. Move this over here. Okay. Beautiful. Okay, now we need the breadboard. Oh crap. Oh my god. Can I pick up the keyboard? My computer just locked itself out because I've not been touching it for like the past hour. So, there we go. Oh my god, my desk is such a mess right now. Okay, caffeine mode. Yes. Do not turn off. Do not turn off computer. All right. This is a very upbeat, Streets of One cover. Okay, so that's a power switch. Okay. So this wire is attached to VCC, so I'll attach it into this bar. Likewise with ground, I'll attach ground into the negative one. And actually put them up here. Okay. Okay. The LED I don't care so much about, but the power we're going to need. Okay.
Piano time, my favorite.
All right. crap. No, I just plugged that one in. Okay, get in there. Shit, hang on. Is that every wire? No, this one left. Alright. So... So I think the conventional guidance is like you should just try shorting things out and see how it goes. I'm not going to do it with a piece of wire. I'm going to do it with this, which is a 10 ohm resistor. So if for whatever reason it is something which does not it's not meant to have power spliced over it, it won't be completely screwed. So, do I have a... So, what I'm going to do is I'm going to take this alligator clip, I'm going to jam one end into the positive, and then on the other end I'm going to attach my cheeky 10 ohm resistor. Actually, yeah, just to confirm that is actually power. So I just realized I took the board at its word. I didn't actually test to see if that was correct. Oh my god, this horrible Doom remix has gone on for freaking... Oh, okay, it's seconds away from finishing. There we go. So... Okay, 4.5 volts. So... Okay, so it is going over the battery pack. So maybe if we change our probe to the ground. Oh wait, I'm in the wrong. There we go. Okay. Alright, so okay, as expected, the test pads near the switches for the keyboard are in fact attached to the same thing that the keyboard is, so we can trigger off key presses pretty easy. All I'm doing is I'm just tying ground to that test pad and it registers as a button press. I wonder how, like, does the keyboard do anything for the other music things? This is pretty good. Okay. So that's okay. That's all well and good. Now, I guess, yeah, being like a modern IC, it has like a clock source on board, which means we can't do the old, like, the same trick that we did with the TI speech chip, which is mess with the clock source. At least not obviously. I mean, there are some... Accenture asks, can it move the Doom theme? It only supports a C major scale with no no harmonics. At least not sorry, no flats. At least without modification. But so actually, yeah, to answer your question, the Doom theme's in like A minor, isn't it? Oh no, it's an E minor. Yep. Nope. Go back to the cows, please. Okay, is it just a dedicated cow button? Okay. Yes, it is a dedicated cow button. And then there is a quack button, I think, next to it.
Quack, quack, duck.
So I don't know, what can we do with this then? We could have like some kind of, we could try setting up like some kind of circuit to just strobe all the keys. Like that seems like it should be possible. We could also try messing with like the power going into the keyboard. Let me grab another piece of proto wire. Oh my god. Work with me here, proto wire box. Okay. So if I put this here on ground, I'll just leave that there so we can test. Interesting, okay.
Piano time, my favorite.
So shorting this capacitor to ground,
Piano time, my favorite.
this is interesting, okay. That's the same as pushing this switch here.
Piano time, my favorite.
These passives, if I try and ground them.
Piano time, my favorite. Quack, quack, duck.
Oh, I see, okay, so... Oh, okay, so this must be the equivalent of just grounding this switch, which would be the same as grounding the test pad for the switch on the other side. Okay, that's not really what I wanted.
Piano time, my favorite.
I wonder what happens if I try and ground like the data lake of the flash chip while it's playing back a sample. Would that be good? Chat, do you think that would help? That's interesting. Yeah, it does not like that. Okay, well. Okay, well, I guess there doesn't really seem to be very much external circuitry. We could try just, we could try reducing the amount of power that the board gets and see if we can glitch it out that way. But I mean, it's pretty robust. Like, I was raking that, raking the ground pin over it quite a lot, and it just seems to bounce back pretty quick. I wonder what happens if I change this to... Oh, what happened there? Oh. So, okay, maybe... Alright, and then... Okay, so this is 4.5 volts. I should probably check to see what voltage the memory chip is running at before I go ahead and poke it. That would only be polite. So 8 is... So here's the data sheet for the little memory chip. And we can see that pin 8 is VCC. So I'll just... get my multimeter out. Ground is 4. Okay. Oh my gosh. Okay. That? Come on, that should be ground. Why are you not? I'm doing so wrong. Hang on. There we go. Ground. .4. Weird, okay. This memory chip doesn't appear. Am I okay. Yeah, VCC should be the freaking top right one. Why am I not picking up anything?
Piano time. My favorite.
Okay, now we are. Oh, interesting. Okay. So there's only voltage being consumed when samples are being played back. Really?
Piano time. My favorite.
Yeah, that's interesting. Okay, so this system on a chip must have a regulator which gives power to the flash chip. Equals03 says perhaps dinner and a movie too before. You're gonna have to elaborate, I feel. Like this is a child's toy. I'm not making the connection. Okay, well. But that is okay, but that is interesting. That does mean, so if I turn this off and I switch to continuity buzzer mode, let's switch back to big camera. So that's attached to ground, so that should buzz with ground. Yeah, okay, so that's ground. And ground on the chip is connected, but I'm reckoning that this voltage pad is not connected to the main 4.5 line. No, it's not. It's probably connected to one of these lines going into the blob, into the epoxy blob. Oh, Equal says it was a while back, the moment was missed. Yeah, apologies. Yeah, my neck is kind of craned down most of the time while working on this stuff. Alright. Huh. So this I mean, what kind of is there even, there must be a regulator, right? Like a voltage regulator. Like how is this, so there's a battery box in here which contains 3 AA's that has these wires coming in through here. Oh yeah, so there's 2 wires for the speaker cone and then 2 wires for the power. And then if we pick this up, yeah, okay. Ground gets attached to ground, and then oh, okay, and then we've got like a, I think it's a single, is it a single pole double throw? Or is it a... No, it's like it's a 2-pole double throw, I think, because you've got, yeah, so 2-pole double throw switch. Actually, crap, no, it wouldn't be, would it be a, no, it's got 3 settings, so maybe it's not a double throw? I don't know. I don't know much about switch methodology. But yeah, power goes in there and then it gets directed. Well, I'm guessing like one of these poles is used to like give power to the board at all. Like obviously when the switch is down there, there is no power being sent to the board, and the other two there is. And then the other one is used to indicate what activity it is, which I imagine is what these two test points are for. Oh, sorry, what volume, I think? I think it's a volume switch. Right, and then that... Okay, that gets filtered through two capacitors. And then... Okay, and then this goes into the glop top. So what, it's actually...
Song. Press
Ozzy,
the
Miso.
note to pick the song.
Oh, thank you very much for the follow, Dystopian Spell. good to have you around. Okay, so it's got SPI. So SPI, I think, is... That would be the bus that's used to communicate with the flash chip, I believe. Yeah, typical applications include interfacing microcontrollers with peripheral chips for secure digital liquid crystal displays, blah, 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 blah. Because, yeah, like on the bottom of this board, we have test pads for SPI down here. And then up here, we have data and clock, which I think might be single wire debug. Or simple wire debug, or whatever it is. Serial wire debug. Oh, okay, no. Serial wire debug is SW clock, and then the other one is SWDIO. Res data clock debug. Really? You're not going to show me the page? Okay, fine. JTAG, res data, clock. No, not CKJ. Oh yeah, and is there... No, okay, I thought there might have been TDI, but I don't think there is. There's res data clock. Mosey Miso S clock. Yeah, okay, so we've got Mosey Miso S clock, and then chip select, which is all down here for access over SPI. So I wonder then, like maybe it's possible to access I was gonna say, like, maybe it's possible to access this flash chip without having the microcontroller turned on at all. If it is, though, then... What I don't quite yeah, like... What is the deal with, like, just giving it power, like, the very second you need it? Anyway, well, we're coming up to the stream halfway point. I think what I'll do here is that I will take a quick break. I will wash my hands thoroughly because I've just been, like, touching a bunch of lead solder, and that's obviously not great. But then when we come back, I will try and you know, I'll dig up my JTAG and I'll dig up my Glasgow, and we'll see if we can actually connect to the chip on the board and see what we can have a look at, because I feel that I might get more luck via that path than by glitching it externally. Or maybe I just don't know what I'm doing enough to glitch it externally. Anyway, I'll be back in about 5 to 10 minutes. Go treat yourself. Yes. Where's the... Okay, where's my... Sorry, my console is, like, all the way over there out of reach, so I'm gonna have to, like, rummage around until we can find... Hey! Hello, everyone. Look what I found. Face. Sega reliability is built in. In this box, we have both an educational J-Link and a Glasgow Digital Interface Explorer. So my thinking is that one of these two is probably going to be able to access the SPI chip. In fact, I'm just going to take out the little getting started card for the Glasgow and have a look. So what have we got? We've got status LEDs, a bunch of general purpose I/O. Yeah, okay. It looks like it's all general purpose I/O. So maybe we should just download the Glasgow software and just properly see what the options are. Because I haven't actually, this is the first I've had the Glasgow for a while now, but I've not yet had the opportunity to really use it. So this seems like a good a time as any. So let's go back to the desktop. I may as well tilt Yay camera back up. And let's get Glasgowing. Glasgow Digital Interface Explorer. There we go. There it is. What is Glasgow? Glasgow Interface Explorer is a tool for exploring digital interfaces aimed at embedded developers, reverse engineers, digital archivists, electronics hobbyists, and anyone else who wants to communicate with a wide range of digital devices with high reliability and minimum hassle. That's us in a nutshell. Okay. Oh yeah, I could probably turn the music back on. Oh yeah, like on the break I was thinking like, okay, if we were to reprogram the flash chip in this piano, what would we replace the sounds with? And the thing that kind of sprang to mind was like maybe like if we nicked the sound effects from like Doom, like just kind of demonic shrieks and yells, like maybe that'd be fun to replace the farmyard animal sounds. Because yeah, the flash chip on this thing is like there's 8 megabits, so 1 megabyte, which would be, I mean, I imagine there'd be quite a bit crammed in there because it didn't sound like the highest bitrate, the highest bitrate audio. Glarkelf suggests more on Ash soundboard. It would just be like PC bleeps and bloops. There are no digitized sound effects in Moron Ash, only PC speaker. But control pins is GPIO, UART, SPI. There we go. Initiate SPI transactions. That's exactly what we want to do. We want to SPI the shit out of that. Except, I don't know. I don't know much about. Oh, read and write 25 series SPI flash memories. Maybe that's what we want. Identify, read, erase, or program memories compatible with 25 series flash memory such as Microchip, 25C30, Winbond 25QX4, Macronix MX25. I mean, we're looking at Macronix MX25 V8666. Well, hundreds of other memories that typically have 25X, which is X. Yeah, okay. So we've got X25. That seems close enough. So, good. This is exactly what we want. So when using this applet for erasing or programming, it's necessary to look up the page and sector sizes. Okay, so I think we just have to install the Glasgow tools. which, if I recall correctly, is a Python package. Maybe I'm mistaken. Installing and updating. Okay. In particular, every dependency is shipped by the Python package index. Okay. Did I put Glasgow's config into my device rules? Sorry, I'll be right back. I don't have any tissues within range, and I really need to blow my nose. Okay, that's better. Alright. Oh, I see. Right, that's what we need. Okay. Have I checked? Okay, so okay, I have not checked out the Glasgow source code. Yep, okay. So I'm reading it. I'm not just copying stuff blindly to my udev config. Yeah, that's probably the Glasgow vendor and product ID. I have no reason to doubt that. Okay, and then we just reload the udev rules. Okay, that's where I screwed up. Okay, good. That's all building. Okay, now how do we plug... How do we plug this Glasgow in? Okay, it's got micro USB. Oh, sorry, not... It's got USB Type C. And... Huh, I thought I had a Type C cable hanging around specifically for jobs like this, but that was before I inundated my workbench with children's parts, children's toy parts. Okay, well I have... Yeah, okay, I have this one here. It's not USB 3, but it'll do. Lights are on. Okay. What have we got here? Okay, install package Glasgow using 5.3. Glasgow. So if we go version, Glasgow list. Oh, found RevC3 device at API level 2, supported API levels 4. Please run Glasgow Flash. Yeah, okay, why not? Power cycle the device to apply changes. Yoink. Plugged in. Okay, good. What we got? We've got voltage, safe, voltage limit, REPL, script, multi-tool, flash, build, test, factory, and list. Okay. The steps, okay, the steps above install the YoWasp FPGA toolchain. Fine, alright. And then using the device. Getting started with Glasgow. So we've got the Glasgow tool. Sure, okay. Okay, let's so safe. There we go, all ports safe. Working with applets. Glasgow is based around the concept of applets, with each implementing a particular mode of operation or interface. For example, there are applets such as UART, I2C controller, and SPI control. We want memory 25x. So, if we were to go Glasgow run memory 25x. Okay, and then we have to provide chip select IO SCK. I see, alright. Using an applet from the REPL, scripting an applet using an offline tool. Identify, read, and erase, or program memories compatible with 25 series flash memory. I see, okay, so... The default pin assignment follows the pinouts above in the clockwise direction, making it easy to connect the memory with probes, or alternatively crimp an IDC cable wire to an SOI chip. It's also possible to flash 25 series chips using the flash ROM applet. Okay, we don't have that. Okay, so we have Copi Supo WP hold the pins. Oh, I see. Okay, and you can attach. All right. So I think we just kind of like match up these numbers here with the numbers here on the Glasgow panel. We should be able to do this. Is there anything else in the datasheet that we should learn? It's like VCC, for instance. Tell me about, like, when I hit it with the multimeter, it looked like it was about 3.3 volt that it was getting. Oh, come on. Tell me about VCC. I want to know all about VCC. Okay, VCC to ground potential, so minus 0.5 to 4. So yeah, it's meant to be 3cc. Well, good on it for not being destroyed when I tapped it with tapped it with the probe. But then again, that's why we put in our that's why we have our safety resistor. But and it's still okay, right? Yeah. Yes. Okay. So we'll turn that off. Oh, I see, and that's why there's... Okay, there is a separate little pad on the board for SPI power, which makes sense, because SPI power is not the main power bus. Alright. So I think if we solder up wires to all of these little guys, and then attach them to the Glasgow, we might be able to rip the samples, / change the samples, which would be kind of cool. So... Let's see if we can do that. I'll just readjust the camera. So unfortunately, there's going to be more soldering, but we might get a nice payoff, so let's hope for that. Oh my god, this clip. I hate this clip. crashed. Huh, okay. Oops. There we go. That was much easier once you get your eye in. Oh great, what did I do? Oh. I slammed my mouse. I slammed the button on my mouse which hits the back button on the browser, which is exactly... I've always wanted that. It's my favorite mouse button. I use it more times than I use the left click. Unfortunately, never when I need to. Okay, great. So, okay, so we're gonna need some more lengths of wire. How many we got? 6. We can do that. One, 2, 3, 4, 5. Just need a couple more. Let's prep the yeah. I just turned the iron off because it's generally not great for the tip to just let it bake like that. So may as well get all the wires prepped, then we'll turn the iron back on. Hey Stigo, how's it going? We're just in the middle of, well, we've soldered a bunch of wires to, this Fisher-Price children's toy. Where's the picture? This guy, up in the top right. We were hoping we were able to do, like, some circuit bending, but it seems like it's mostly, like, most of the logic is happening inside the microcontroller. However, possibly because this this toy is quite new, it's from 2018. There are debug pins, both for the chip, which are up here, and for the flash, the SPI flash memory, which are down here. And we're about to solder some wires to the flash memory ones to see if we can use this Glasgow Interface Explorer to modify the sounds on the children's piano, because right now it's like you've got yeah, it's like a keyboard, a cow, and a duck, and something else. But we were thinking, like, I don't know, maybe like swap it out for like the Doom sound effects, if we can do that. I'm assuming that the contents of the flash memory is just going to be some kind of PCM or ADPCM format. It's like, yeah, 1 megabyte of flash. So quite a lot. But yeah. But in order to do that, we need to solder some wires onto the pads. So that's 2. Just twisting the ends so we can use them. That's 3. It's 4. It's 5. It's amazing how much quicker things are. Like, if you just group all of the same activity together, it feels so much quicker than task switching all the time. This is something that, very similar when I was doing all of those animations for the game. Like, it really did help to just only focus on drawing outlines or filling in flesh or what have you. Okay, and that's 6. I better just make one additional one of these. Right. Okay, now we turn the iron on. Yeah, okay. So what are we gonna... So... To interface with this... We could... Actually, what am I saying? Like, easy way. We can... Take some of these... Let's plug it in here. Oh, okay. One, two, 3, 4, 5, 6, 7, 8, 9, 10.
Please fasten your seatbelts.
Oh, thank you very much for the follow, Pilmos. Good to have you around. How to... Actually, where's the little Glasgow card? Oh, I get it. Okay, so there's... So the top left pin is voltage... Okay. The LVDS port requires I/O reference voltage to be provided via the VIO pin. Okay. The LVDS port pins can also be used in single-ended mode. They're not limited to differential mode only. I mean, we're like, ideally the Glasgow should be providing the power, not us. Yeah, so you can configure I/O port voltage to this. When using this applet for erasing or program, it's necessary to look at the page and sector sizes. Fine. The default pin assignment follows the pinouts about in the clockwise direction. So, VCC IO3. Oh no, okay. AO is hold. SCK is A1. Copy, okay. And then that should correspond with... Okay, it's slightly different. It's called something slightly different, but it's essentially, yeah, the same pin out there. Okay. Oh. Stiga says, I recognize this tune, but I can't place it. According to this, it's Crockett's Theme by Jan Hammer. This is something else. Okay, so if I were to peel off a bunch of these. Oh, actually, do I have a... I have one of these. I think this came with Glasgow. It must have, because it didn't come with the J-Link. J-Link was way too stingy to come with that. It came with, I think the J-Link came with one ribbon cable, which I then lost. Okay. Yeah, that's nicer. Okay, so if we take one of these and we plug it into port A. Okay, then we suddenly have all these breakout leads. Which are either going to be ground or numbered. Oh, Stiga says, also known as the theme to Miami Vice. Ah, that's right. Yeah, like that's where I remember that. I remember that Jan Hammer did the music for Miami Vice because I think Ken Williams hired Jan Hammer to do the soundtrack for one of the police quests, and it wasn't as good as, it wasn't quite as good as Mark Siebert pretending to be Jan Hammer. Okay, well we've got all these leads. I'll pop that down there. Hopefully we'll be able to solve that in. Dr. Buttdota says this looks like God's work. What does? Just like modifying a toy to be evil. I guess it's work of a sort. Oh, I haven't even attached this wire. I should attach that wire. Okay. Come on. Come on, wire. There we go. Oh, cool. I turned the soldering iron on and I forgot. That's great news. Oops. Good enough. Alright. Tweezers. Equals 03 says, I'm amazed that you have managed to keep track of all the wires and where they should go. I would definitely need different colors or something. Honestly, like, I mean, I don't really need to keep track of them just yet. I know that all of these ones here are just attached to the keyboard pads. We will need to keep track of, well, you know, also the board is labeled, which means when we need to plug them in later, we should be okay. Come on. Please stop tilting down. Sorry, tilting up. There we go. Crap, I should have fluxed this. Oh, that's okay. That's fine. Dr. Bugta says, is the chip on the PDF the one on the board or the one you were connecting everything to? Yeah, so the chip in the PDF is the 8 megabit flash chip, which is on the board. And according to the markings down here, like basically like this board is designed in the factory so that it can be flashed to whatever the target language is. And part of that is that it's got debug pins here for the microcontroller and debug pins down here specifically for like reprogramming the flash. So I am attaching wires to the flash pins, and then we're going to see if Glasgow can access the flash, like if we can dump it, see what's on it, and then conversely write to it. But yeah, I've never used I have had the Glasgow for a few months. I've not used it yet, so this is exciting. It's also exciting because I kind of assumed that newer toys would be kind of worse, but really, it's just like, what do you call it? Toys made after like 2012, 2013, like when microcontrollers with simple wire debugging became super cheap. Like at that point, there's no reason not to just make the board programmable if you're doing, I don't know, if you're a toy company making multiple SKUs. That's good news if you want to hack it. Come on. Love those solar fumes. Love them. I am like running... I do have a window open and I am running my background air conditioner to try and hopefully fumigate the room before I... But at the same time, like, you know... all the baby boomers, like, breathed leaded petrol for, like, 40 years, and they turned out alright, didn't they? They didn't turn out insane. That and drinking from the hose. Really? Yeah. I really should. I really should actually just buy some lead-free solder, but what can I say? I've got. This is what I got. This is what I got for now. Dr. Buckdotter says, the solder I'm using is ancient, it's bound to have unreasonable amounts of lead in it. Honestly, the main thing, I mean, you know, if you're selling electronics, you can't have lead in the solder anymore, but the main thing is the Fluxenet any good? Because, I don't know, this stuff I've got here is what, half a mil thick and has quite good flux. And I don't know, like the original roll of solder that I had years and years and years ago was very thick and the flux in it was garbage. And I was wondering why it was so hard to solder. And the answer was, I should have picked thinner wire. Oh, crap. Tweezers. Always use tweezers. Oh, Dr. Buckdotler says... oh no, Stiga says, I've heard lead-free solder is stubborn to work with, different heat requirements. You do have to heat it up quite a bit more, apparently. I'm running... I mean, right now I'm running the iron on 400 degrees Celsius, which seems to be alright. Maybe... I don't know, I haven't really worked that much with lead-free, so I can't tell you more than that. Dr. Butler says, the soldier I'm using is ancient, it's bound... Oh no, that's previous message. Said, it was sitting in a shed for a decade or two before I got my hands on it. Yeah. All I can say is, if it feels like it sucks to work with, just bite the bullet and buy a nicer reel. And, yeah, flux syringe, game changer, yep. That's what this guy's for. No clean flux. Once you kind of figure out that when you're soldering, it's about tricking the solder into flowing places. It's not about melting solder into things. It's not about scraping solder into things. It's about letting it flow into places. And flux is just good at you know. It's good at convincing the solder that it really needs to be somewhere. And there's a bit of it in the actual solder, but putting on the board, yeah, it's pretty good. It's pretty good. Come on. Alright, last one. Beautiful. Alright, turn that off. Okay, those are all wired up. Alright, get out of here. Alright, now we gotta switch back to desktop. Where are the Glasgow instructions? Oh, here. The default pin assignment follows the pinouts above in the clockwise direction. May use it to connect memory probes. Alternatively, crimp an IDC cable wired to a... That's okay. So, we've got a Glasgow here. Configure IO port voltage to spec. So there is one of the pins is marked V on here. If I trace that through, and it's red. Let's just try it. Let's just try connecting that up. So this is okay. Not the best connection, but it'll do. Dr. Bugdiller says the Glasgow looks great. My only foray into SPI stuff was trying to reflash the bootloader on a bunch of broken, nice nano clones. I managed to flash one into a working state, but the Bluetooth on it did not work. But I used a Raspberry Pi for that. I do have a box full of Raspberry Pis somewhere, but this seems, I mean, this looks like literally, it couldn't be any easier. You literally just say it's a 25x type memory chip and it figures it out for you. That's pretty damn nice. Not gonna lie. Okay, so we don't have a... So this chip doesn't seem to have a hold, but that's okay. We'll connect... We just won't connect anything to that one. So then, okay, so then we just need... So that's hold... SCK. Okay, so which one is SCK? Okay, this one is SCK. Oh, Dr. Button says no level shifting on the Pi, I don't think. As in, like, variable voltage output. Yeah, isn't the GPIO, like, fixed to 3.3? Or something like that? Oh, good lord. Okay, I want the number 1. Where is the number 1? though. This is... Okay, no, this is... the crimped pins are not a good fit for this. This type of twisty wire. I'll have... Let me put it onto the, put it on the breadboard. Okay. Let's have the SCK one. Sorry, I've got something in my eye. I'm gonna have to quickly break. I'll be right back. There we go. Apologies, I was like really wanting to just dig my filthy lead-covered fingers right into that eye socket, but yeah, I had to go wash that all off before I did that. We're good now. Okay. So yeah, I was going to try and plug them directly into these kind of little crimped proto connectors, but the twisty wire is not playing ball, so I'm just going to send it through the breadboard. Okay, so we've got SCK. Then we need SIO. So this is where I might actually have to like do a... I might have to do a continuity test because I'm not sure what... Yeah, because the markings on the board don't quite match up with either the markings on the datasheet or the markings on the Glasgow documentation. So we're just going to have to do a little check. So we have MISI, MOSI, and MISO. So if I grab like the wire for MISI. Touch that. Which pin? Okay, so it is pin number 5 on the datasheet. So it's the one directly after clock. Then we've got whatever this wire is. Come on. Okay, so pin 2 on the data sheet is this. So 1, 2, 3. Okay, then we've got chip select, which is going to be pin 1 on the data sheet. Ooh, write protection active low. Okay, and then that just leaves this wire. Is that attached to the write protect pin? Huh. It's unclear what that's connected to. Oh, is it connected to VCC? Oh, okay. SPI has 4 logic... SPI has 4 logic signals. Variations may use different names or have different signals. There's slave select, serial clock, master out, slave in, master in, slaved out. What I don't understand then is... we've got master in, slave in, and master in, slave out. Okay, well... okay, the pin of WP will remain internal pull-up function while this pin is not physically connected in consistent configuration. However, the internal pull-up function will be disabled if the system has a physical connection to the WP pin. Anyhow, we should be able to at least read the chip. Come on. So I have this mystery pen, which I'll just plug in over here. We have that, and I guess ground, which is here. That's the power. It's more like it. Oh, whoops. Face. I'm just picking through the wires, trying to find the numbered ones. There we go. What's that? It's 3. Oh my god, come on. Zero, 1, 2, 3, 4, 5, 6. Okay, good. Then for ground, we just attach. I think we can just get away with attaching 1, but it's probably not. I wish I had more of that room. We'll attach a few to ground. It's almost like one pin which is cooked. Come on. Oh my god. Alright, great. I'll just... Please. Okay. So that's everything plugged in. Okay, choose from identifier, read, fast read, program page, program, erase sector, erase block, erase chip, erase program, project, verify. Okay, let's go identifier. No electronic signature detected, device not present. Okay, fine. So if we go v 3.a equals 3.3. Oh, right, I've got it around the wrong way. So it should be like VA equals 3.3. No electronic signature detection, device not present, device not have valid SP. Okay, well. Is Glasgow actually putting out power on that port? Yeah, okay. So the power line is throwing out 3.3 volts. It's definitely sending out Okay. Oh wait, no, that's SPI controller. No, not that. Or this. Alright, so according to the docs, it should be using A0, A2, A4, and A3 and A5. So just double check that A5. That should be attached to the chip select. No, it's not. I screwed up. Okay, so it's not attached to the correct wires. Glasgow. Glasgow safe. So which one was the chip select pin attached to? Oh, okay, yeah, I got it off by 1. So okay, A3 is the right protect pin, but okay, input. Okay, I mean we could try it again with this arrangement, I suppose. Identify. Look at that. There we go. What have we found? We've got Connexon, Rockwell, Macronix device. Device is a valid descriptor, SFTP table, and yeah, it's self-described and it's found 1 mebibytes. So yeah, 8 megabits and 1 megabyte of sorts. So how do we rip it? So there's fast read, or just read. Let's just do read. I think given that we're using like a ton of exposed wires, it's probably best that we just do slow read. Okay. So read memory starting at address with wraparound. Read length bytes from memory. Okay, let's try that. So that. So I'll say read F. What was this thing called? It was called a light up. Silly sounds piano.bin. And we want it from address 0 and we want it length how many megabytes? Actually, we can tell from the datasheet. The datasheet should tell us. 8388608. Come on. Yoink. That's done. Alright, so MRC hist. Silly sounds piano bin. Oh, interesting. There's some data, but it seems to be repeated. Like, what's the deal with that? You also okay. It's definitely got some kind of wraparound going on. Yeah, sector size 4 kilobytes, block size 32 kilobytes, program buffer size. Oh wait, no, that's a comparison. Get out of here. I want the data sheet. Oh, okay, no, that's the okay. No, yeah. I got the math wrong. So it's 8388608 1 bit. So if we're I need to just divide that number by 8. 1, 2, 3, 4, 5, 6, 7, 8. Yeah, it's 8 copies of the same thing. Because that's so really we just want 0x 10000. There we go. Samples. Oh crap, sorry. Wait, am I? Oh no, I am looking at the desktop. Sorry, I was looking at the wrong window. Hey Helco. Helco says, wouldn't 8M be 8 megabytes, so 8 times repeated? Typically, memory chips are dealt with in bits as opposed to bytes. And I think, yeah, in this case, like if we look at the datasheet, it's, yeah, 8388608 times 1 bit structure. So I just typed that number in thinking, oh, it'll be that many bytes. But then after employing some reading comprehension, I realized, oh, I'm going to have to divide that by 8 to get the number of bytes. So we can see here, like, most of the flash memory is not used. Which seems kind of a shame. I just want to... I'm also kind of conscious that... Oh, here we go. So... there is definitely some kind of packing going on. We can see kind of like there are these bands here. Like that looks kind of like deflate actually. A little bit like deflate. Or it could be ADPCM. I think ADP PCM also has similar bands like that. So we might, and and there's also like a little kind of bit at the top which appears to be just header information, maybe. Okay, so what do we got? Okay, so there is no yeah, okay. It's just well, I mean, we could see that the chip powered down whenever it wasn't playing back a sample, so obviously the code isn't in here. The code is in the flash memory and the microcontroller. But I'm guessing this must be like an offsets table for like places in the flash memory to get sample information from, perhaps. Okay, and then down here we have our data. Okay, that's a little annoying. I was kind of hoping that it would just be plain PCM, which would then make it real easy to just play back, but it's not that. Otherwise, like, if it was plain PCM, we'd be able to look at this histogram and it would be very symmetrical, but it is not. It is some kind of compression going on. It's not, I mean, it's definitely not deflate, because we can see that there's areas of lower and higher entropy. If it was deflate, it would generally be like all roughly the same shade instead of kind of... I'm guessing like areas like this would be like quieter bits of the sample which don't have that much data to them, perhaps. So I don't know, what would be... I suppose, yeah, the other thing we could try and do is attach the microcontroller's debug pins and see if we can learn anything from that. Or alternatively we could, I don't know. Yeah, it's good. It's going to be some kind of 80 PCM. However, you sort of need to, like, I mean, we could go like FF probe, silly sounds, but it's not going to find anything. I mean, okay, let's... If we look at some of the stuff in here. So we've got 1 BCC seems to be when the first lot of wave data begins. Does that appear in the header? Does 1B even appear in the header at all? No, it does not. Okay, so... So if we have... Interesting. I'm just looking at ways to kind of split this data up. Because yeah, it seems like clusters of 4. All the way up until about here. And then that could be 100, which would be the count. Oh, sorry, 256, which would be this. And then I guess there'd be like another array of 100 here. Okay, we can try splitting this stuff up. Except, great. Mad Moose says, how big is the file? Yeah, it's not that big. It's about 4D000 bytes, so... Yeah, about 315k. So yeah, barely uses like a third of the ROM space that's on this thing. Okay. Oops. Sorry, I'm juggling stuff around on my desk to try and get my keyboard back. There we go. So we'll say unc equals MSC byte. Oh, sorry, unit 8. Count. Okay, if we look at the numbers here. Okay. 0 seems unused. This seems like a... maybe like a flag or something. This seems like a 2-digit number? Yeah, a little endian 2-digit number. Or sort of two by number. So say, oh. Okay, and then that's immediately followed by... Okay, then after that we have this slightly more complicated dingus. Which then I guess becomes this around here. Alright, let's just try those two for now. Okay. So we have a big list of offsets, or at least they look like offsets. And if I were to like take, if I were to take the first one, eight 503. Yeah, okay, it kind of just starts up here in the middle of... right in the middle of the blob. Whereas the blob... really kind of begins as far as we know here in 1BC0, so... This is unusual, but not helpful. Okay, and then... Okay, so we've got to figure out what the cadence of this thing is. Oh, that was actually quite easy. So that is... ah, crap. 12, 13, 14, 15. Weird cadence, but fine. Let's just go by its length 15. Yep, okay, that's that data. Oh wait, is it that data? Seems to, maybe I got the cadence wrong. Because the first two sort of worked out. Then we're just kind of way, yeah, we're off in the weeds. We're off in the weeds. There might actually be a lot to it. So I see like 8001FF00 goes all the way back up to here. But then it's also repeated down here, so it might just be a bad a bad sequence. No, that looks about right. 80, 0, something else, 0, 0. Like, yeah, that looks like part of the pattern. Twelve, 13, 12, 13, 14, 15. Alternatively, maybe the easier way is to find where this pattern begins. Mamu says, yeah, most of the numbers in the table above seem to differ by about 15, so that tracks. It just seems like it kind of might go out of phase a little bit. Um, yeah, like look at this. It just kind of wraps around when it. I think, like, oh, these must be like variable length, maybe. Because down here, down here, it seems to be kind of consistent. But then, yeah, because like what we're looking for is maybe like some clues about the type of ADPCM encoding to use. Because there are many different options. FFmpeg detect ADPCM type. I can't remember if there's a statistical way of like determining like what type of ADPCM it is. I just remember that there are, you know, there's a lot of different codec types. Mamo says ScumVM has a couple of ADPCM encoders. I wrote a couple. Yeah, like it doesn't take much to like tweak an ADPCM format. Hey, and I mean, I guess if we were desperate, we could attach the debug pins for the CPU and dump the firmware and like see how the firmware does it. But I guess that's also kind of like predicated on like the CPU being a type that we can dump with the J-Link or perhaps the Glasgow. Yeah, alright, so this one goes 8001FF. This one continues, but then at the end it goes 0 instead of FF. And then it looks like slightly different data going on. Like maybe that's like an additional record after this. Like FF could imply no additional record and then this does. At which point then we get to another record which... Sorry, a new record. Which again, that finishes with a 1, which then follows up with another thing. Okay, and then these ones here that finish with F, they are the same cadence. So, what if we... And then we just say that if extra doesn't equal -1, or if it equals 0, then we add some more junk to the end, I think. I don't know. How badly do I want to, like, take, you know... I was excited by the idea of writing a decoder for this until I got to this section, and then I got less excited. Variable length data is not fun. And if we take, like, a sample of this... DC8, 9... Okay, these are all the ADPCM formats that FFmpeg supports. Quite a lot of them are kind of game-specific ones. But I don't think that we'll be using... I'm guessing we'd be using whatever... Provide a proper ADPCM... Yeah, like, I'm assuming that it would be, like, something that supports the ADPCM, like, the ADPCM wave format. That's quite accessible. That's not too difficult to... ADPCM IMA wave, maybe. Okay. Just to close the question, here's 2 ways to convert audio into a wave with ADPCM encoding. Let's just try that. Let's just grab a completely random sample. And convert that into something else. So FFmpeg, we'll just nick that FFmpeg command line. FFmpeg I F WAV A codec ADPCM MS Okay. Okay, so this is not the same ADPCM codec, clearly, because the banding is very different. Mamu says you can probably see the lengths in the index table above. That's actually a good point. I did not think of checking. So if we look at, like, table 1, has this 16-bit number that is increasing. Oh, actually though, maybe this high bit is not used. Yeah, I initially thought it was the offsets too, but if we look at the hex dump, like, the actual wave data starts at around 1BC0. So these numbers don't really seem to kind of immediately make much sense, but if we kind of ignore the high bit on this and we say just like 503, like what's at 503? 503, look at that! 503 is the start of this table here. Okay, so that's, yeah. We've got our offsets. So let me rewrite this rule here. So, I can't remember how my own library works. Okay, so we go bit 16, endian, little. Offset. And that would literally be 0, 1, 1, 1, 1. 1, 1, 1, 1. Oh, sorry. 0, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1, 1. Oh, yeah. So it'd be 0, 1. Okay, let's try that. Yep, we've got a lot of stuff. Print X. Did that fix the math? I think it did, yes. Okay, that fixed the math. So what are the differences between these? They look kind of sparse. Yeah, the delta between them might give you the lengths. Like, I think that might be what we'll need to do. So for I in range, X rec 1, X in enumerate. Yeah, okay. Like, most of the time it's just 15, but then other times it is a multiple of that. So that's cool. That's a cool thing. Alright. Alright, so then we got all that stuff, and then immediately after that we have another giant table. And then I'm trying to remember. Okay, so we had... Yep. Oh, but we can't do that because it's not... It's not a linear store. Oh, store ref. That's how we meant to do it. I remember now. Oh, but that includes the damn size as well. Far out. Okay. Okay, you can define a store ref without a size. That's... I guess that's possible. Alright, let's just hack it in there for now. Is it? We'll try that. Yep, mostly 15, except for the ones that aren't. So like, we can go X in here, hex dump. Oh, except for the one at the end, which is obviously too big. Three, 7, 8. That number rings a bell. That's a frequency. That's a goddamn frequency. It's probably gonna be like 8,000. Oh. 15992. Okay. That was close. That was close. But like all of these records seem to have like 37898 9A80 on them. I mean, there could be a playback frequency. Something is still off though, because the positions are still jumping around when they should not be. One A2D. Yeah, okay. I guess it. Okay, so I guess this section here is in fact part of the initial table. So I'm glad I didn't kind of go off and try and figure that out. So C, D. Alright, so according to that number, I guess it should start there. So then the next number should be 1A4C. Which is 6732. Ah, but it's off by 1. 6731. 6716, 6731, 6. So if I go start 6716, and then okay, that's sensible looking. So what the hell is my dumping code doing? It's doing something very not correct. But yeah, what do we got? We've got flag, flag. This, which could very well be a frequency. This, don't know what that is. And then another small number, 375, 885, okay. Oh, I know what I did wrong. I know what I did wrong. The base offset is 0. I don't think. Yeah, okay, fine. I mean, 0 should be... 0 should be correct. I don't know. Okay, okay. That uses... Because we've still got to figure out what codec this is. This document describes an IMA adaptive differential pulse code modulation. Blah, blah, blah. Yeah, sure. DPCM. So if I were to remove points APCM. And then we used 80 PCM IMA wave. Oh yeah, it's slightly more banked. There's like 80 PCM Microsoft, 80 PCM Shockwave Flash. Maybe if I use like a richer sample. Games Win16 does.
I'm so tired.
Okay, that's fine. I want to convert it to actually I should use the mono one. Uh, 22K. Silly sounds piano to bin. No. Oh, it's in here, okay. So use the mono one, we'll convert to this, and we'll go tired 80 PCM WAV. Wow. What the hell is this? Yeah. Okay, maybe I just need a bigger sample. What if I just copy an entire song? Okay. No, it's still very kind of... There's some other compression-y thing going on. Why? I don't know. Because they've got so much space. They don't need to do it. But it's not standard IMA 80 PCM. Alright, well, somehow I don't think, like, even if we kind of figure out how the table works, we're not going to really know what codec it is, which limits its usefulness, so maybe we should use the remaining time that we have to try and hook Glasgow up to the chip itself and see if we can dump the firmware. We might be able to, you never know. So we will need to... once again, we will need to solder some more wires and then try and attach it somehow. So I'll just... Okay, let's... not too bad. We just need to solder res, data, clock, and VCC. Oh no, we've already soldered VCC, so we just need the res, data, and clock. So that's 3. That's doable. Oh, something fell off. Oh, okay. All my screwdriver bits fell on the floor. That's great. Don't blob on the top. Blob on the joint. I don't want to go on the joint. Music is gone. Music is gone. And... oh, come on. Come on. Chip player. good. We're gonna take that. Come on. Come on, fingers. 3 more. You can do 3 more. Okay. Alright, we've got the wires wired up. Now we've got to look up I don't know, how to set up Glasgow. As soon as I finish unthreading my mouse. Okay, here we go. Applet index. We've got control GPIO, we've got MCU debugging. JTAG pinout. Oh no, that exposes JTAG. SWD probe. Okay, maybe the JTAG is a better tool for this. Oh, sorry, the J-Link is a better tool for this. Because yeah, we have like a reset pin, a data pin, and a clock pin. And I guess that could bind to clock, IO. And then if I put J-Link, come on, where's the... I thought this thing came with like a little card that explained what each pin on the J-Link did. Perhaps I was mistaken. I mean, it uses exactly the same connector as Glasgow, so we can just use this breakout cable, I suppose. Okay, on the target debug side, J-Link and J-Trace have a male 20-pin IDX keyed box header. Okay, it is pretty much the same deal as Glasgow then. That's convenient. Just use the same type of cable. Right, keys at the top. Okay, target reference voltage. Used to check if the target has power to create the logic level reference for the input comparators and control output logic levels to the target is normally fed from VDD of the target board and must not have a series resistor. Okay. Output from J-Link to the reset signal of the target JTAG board. Yeah, we've got one of those. And then I guess it would be one to the clock. So it'd be like TDI. Oh wait, no, that's the... Oh, the pin is normally pulled high on the target to avoid unintentional resets when there is no connection. Is this music from... Oh, okay. Sounded like music from Minnesota Fats Pool Legend. But that can't be right, because it's only for the Sega Saturn. Okay. Yeah, a lot of wires now. Okay. Oh yeah, that's right. It's not going to work because we've got Glasgow attached to the memory chip. Okay, maybe the solution is to pull this connector out. There we go.
Piano time, my favorite.
Okay, so if I turn this on,
Piano time, my favorite.
where's the ground? Oh, ground's here, okay. Okay. So the main board voltage is 4.5 volts. The reset signal is being held at 4.5 volts. Okay. So that reset is either the... Oh, okay. So the target CPU reset signal typically connects to the reset pin. This signal is an active low signal? No. So it's going to be a JTAG reset. JTAG reset signal. Oh. Oh, actually, no, I can't use this cable with J-Link because J-Link uses every pin, whereas Glasgow has a row of pins, which does nothing. That's okay. We can use proto pins.
Oh.
Bread with bamboo shoots?
Well, this guy uses bagels for miso soup, you know, so...
Bagels for miso soup, you monster. Okay. I can't believe it. For the first time in my life, I'm looking for... Oh, here we go. I was gonna say, these guys here, which have male on one end and female on the other, like, usually I never want these, but today is the exception. I want these very much. Okay, so... put the key... So we'll need to connect up the reference voltage, reset, TDI, which I think will be the data, and then TCK. here. So we've got reset, input, and clock. So reset. Reset input. And finally, clock. Come on. Get in the breadboard. This hole was made for you. Okay, it's cursed. Let me just chop this and try again. All right. Let's see if the old J-Link still works. Okay, so found the J-Link. Connect. Don't really know, but we'll say SWD. Try the default speed. I don't know. No, okay, you have to pick a device. Actually, did I even turn it on? So we've got show, emu list, sleep, log. Select probe. Okay, VTRef is 0. That's obviously not great. Okay, now VTRef is 4.4, so power is on. So SWO should have supported speeds. Show hardware status. Okay, the reset flag is on. Huh. I don't know. I know that Glasgow has like a JTAG pin detection thing. I mean, we just try connecting. Selection dialog. Okay, it's not going to be a Cortex. Because that costs money. It's going to be... I don't know what kind of chip it's going to be. There's a lot... It's probably going to be like a if it's going to be a Cortex, it'll be like an M0 or an M3. Crushing Ceiling says, speaking of breadboards, I'm making bagels for the first time. I was surprised to learn you typically boil the dough before baking it. I looked up a second recipe to make sure I wasn't being fucked with. Yeah, that's news to me too. I've never tried to make bagels, so I assume they arrive fully formed. From where? I don't know. Brain leaking out ears after stream long. Oh, here we go. EV blog forums. There is no universal way of doing this. Depends on your manufacturer. Best you do with London is detect the core type. Oh, okay, so most complete set splices would be in OpenOCD, which would be in Glasgow. Go detect SWD. Oh wait, you can use J-Link software for this? Okay, we've hit the edge of my competence. I'm probably gonna have to do a bunch of reading to figure out how to JTag this guy. Let me get out of here. I'll unplug this. Unplug these 3 wires. Okay. So one of them must have been doing something to the reset signal. Anyway, we're... hang on. Anyway, we're at the end of the time. Unfortunately, we didn't get super far. We did manage to rip the sample ROM out of the Fisher-Price piano. We're not any close to figuring out what kind of 80 PCM format that it uses, which is unfortunate because we kind of need that if we want to mod the audio that's on it. Yeah, I guess I'll just do a little bit more research off stream. Maybe come back on Monday and we'll talk about it some more. Either that or I'll just pick another toy. Maybe one that's more amenable to, like, unfair hardware modding. Anyhow, I'm tired. I gotta clean up all the screwdriver bits that are now littered all over my floor. So what better time to find someone to raid here on Twitch.tv. Okay, oh, Mac is playing an RTS. Let's go say hi to them. Alright, fantastic. I will be back in, 3 days? Thursday. I'll be back on Thursday. I'll be doing director stuff. Until then, have a wonderful rest of your evening. I'll see you next time. Sorry, I'm dying. Bye!